And it was in 1956 where there was the first conference held called the Dartmouth Conference, which is widely considered as the birthplace of artificial intelligence as a field of study. And this is where McCarthy termed the phrase artificial intelligence. The first funding wave for AI came out, and one thing that came out of this was the Turing test. The Turing test is this simple idea that if you had a human who interacted with another human and interacted with AI and could not distinguish which interaction was with AI and which interaction was with a human, it is said that the AI has passed the Turing test. So we moved to the 1960s, 1970s, where there was a lot of early research and optimism for artificial intelligence. There were new developments that came out, mostly focused on problem solving and games, which led to a lot of optimism about the potential of AI. One example of this is the logic theorist, which was designed to mimic human problem-solving skills in the domain of formal logic. It could prove mathematical theorems. This was demonstrating that a machine could perform reasoning tasks traditionally thought to require human intelligence. However, despite this early enthusiasm, the progress in AI faced a few stagnations known as the AI winters. This is because these exaggerated expectations met technological limitations, which led to this reduced funding and interest in AI research. However, as we move to the 1980s and 1990s, we see these expert systems in revival. There's a huge resurgence with the development of expert systems throughout these 2 decades. These systems could only perform tasks which were explicitly programmed. They used rule-based approaches to simulate the decision-making of human experts in specific domains. So this is a period where there are a lot of advancements in machine learning and neural networks. For example, MYCIN was designed to diagnose bacterial infections and recommend appropriate antibiotic treatments using a large set of if-then statements to simulate the decision-making process of a human expert. This is an instance which started to demonstrate that computer-based systems could effectively assist in complex decision-making tasks. This helps achieve performance comparable to human experts in some cases. Then, in 1997, Deep Blue became the first computer system to defeat a reigning world chess champion, Garry Kasparov. This was in a 6-game match under standard chess tournament time controls. This was a landmark event in the history of AI, as it demonstrated that computers could compete with and even surpass human experts in complex intellectual tasks. Deep Blue could evaluate around 200 million chess positions per second, using a brute force approach to search through possible moves and counter moves. This is an example which shows that now AI has moved into this potential of handling these hugely complex problems. Following this, in the 1990s to 2010s, we have these data-driven approaches and machine learning starting to really come through. We now have more powerful computers and the availability of large data sets, which led to a shift towards data-driven approaches and machine learning. Techniques like clustering algorithms gained prominence, and the late 1990s and early 2000s saw significant progress in natural language processing, computer vision, and robotics. So, deep learning and modern AI since 2010 until now. The 2010s marked the rise of deep learning. This is a subset of machine learning based on neural networks with many layers. Breakthroughs in deep learning, particularly in image and speech recognition, were driven by advances in hardware and large-scale datasets. In deep learning, AI learns from large amounts of data rather than relying on predefined rules, like we saw with expert systems and revival. These systems use structures called neural networks, which are inspired by the human brain and are capable of learning complex patterns from large amounts of data. The more data they process, the better they get at understanding and performing tasks. They can improve their performance through experience, essentially learning from themselves. This stage, since 2010, has led to AI that can recognize speech, understand images, and drive cars. Recent achievements include Google's AlphaGo, which beat a world champion at the complex game of Go, and advanced language models like OpenAI's ChatGPT, which can generate human-like text. And that's it on a brief history of AI. I now want to move over to since then. So now what's happening and where do we see things going? So how has data science methodologies enhanced AI applications? Where does data science fit into all of this? Well, data science provides methods for data preparation, cleaning, and transformation, all needed to train AI models. Machine learning can be used to analyze complex data sets, extract patterns, and make predictions, directly feeding into AI applications. And finally, data science methods help in refining algorithms and models by testing and validating AI systems under various scenarios, ensuring that they perform accurately. Today, AI continues to evolve rapidly. Here's just a couple of areas which have benefited hugely from advancements in AI. So in medicine, data science models can help predict patient outcomes, personalize treatment plans, and manage hospital resources effectively. AI algorithms can also be used for diagnostic purposes, such as interpreting medical images faster and with greater accuracy than human radiologists. In finance, AI systems analyze transaction patterns to detect and prevent fraudulent activities in real time. In addition, AI algorithms can make high-frequency trades based on data trends and market movements, maximizing profits. Another example is in climate. AI is improving the accuracy of climate models and weather forecasting by analyzing vast environmental data, and this is aiding in disaster preparedness and long-term planning. Another example in climate is where AI optimizes energy distribution, especially for renewable resources. This ensures efficient grid operation and reduces carbon emissions. There's a growing consensus that some AI systems are now passing the Turing test. A significant turning point in achieving this milestone has been the development of generative AI tools like ChatGPT. Thank you.